Okay, 1 minute more. Okay, are we good to go? Okay, should we just give a minute more for so those who just joined? Please skim this document quickly. Just take a look at it, just skim, just see some words in it, like uh, and then we continue. Okay, can we start? I need a couple of thumbs up or yes or something before we start. Okay, Simon said, good to go. Joshua said, good to go. Let's get like five. Don't worry. If you're not ready, it's fine. Still take your time. One more minute. One more minute. 1 more minute. Then we start. Those who just joined, we're just going through this document. Just came in this document. Um, okay, can we start? I think we should start because either we go through it as we proceed. Okay, so as I was saying, we want to um let's share my screen. Please stop going through the documents now and let's all focus and pay attention. So you can ask questions and everything. Share portion of screen. Oh no. Not share portion of screen. Connect to sorry, I want to connect to my um iPad. Okay. Can you see my screen? Hey, people not respond at all, crowd.
Yes, I can see
Okay,
your screen.
good stuff. So what I want to do today is uh it's pretty straightforward. We just want to design a system, right? We want to design a system. And we just, previously we talked about different parts of a system or different things that compose the system, right? And sometimes you can get to an interview where the system that you design is very vague. And you can get to an interview where they give you a very specific feature. And you can get to a system where it's between vague and a specific feature, right? So let me give examples of that. So an example of a very vague one is this. So we tell you that you live in New York or you live in Accra, you live in Kumasi, and usually you want to have a call, right? You want to have a call. And when you want to have a call, you usually want to go to a restaurant to have that call. It is the case where the restaurants you go to usually it's too noisy for you to have the call there, right? It's too noisy for you to have your call there. So then, how can you solve this problem? That is a system design question, and it's very vague, right? It has so many parts. It doesn't even make so much sense to you. And with those things, you usually have to trim it down and polish it and do things like that. An example of a company that usually asks those questions is Palantir, right? Palantir's system design can be like very high level, super big, and you have to now polish it, refine it, trim it down, think about your data, think about the things you want to handle, and so on and so forth. The second one, which I said is mid between very vague or very general and very specific, is for example, design Netflix. If you interview that's to design Netflix, that is a very, that's a very huge thing, right? Because Netflix as a system, it's not just one thing, right? Netflix is not like a URL shortening thing, right? It's a very, because it has so many parts. It has the recommendation system parts. It has a type ahead system part. Like if you're typing you're typing a movie, it also suggests things for you. It has a streaming part. It has so many parts, right? So it gets same like question like that. So what you want to do is you want to narrow it down to a very specific feature in it. So for instance, maybe the streaming part, right? For instance, maybe the recommendation part, but usually, focus on the core thing, right? Like if you have to design YouTube is such a huge thing. There's a comment section in YouTube. There's a recommendation section in YouTube. There's a video streaming part in YouTube. There's even shorts in YouTube and all those things, right? So when you get to one that is general like that, usually you try to work with the interviewer to narrow it down on the specific or the core parts you want to focus your design on. They know it's very generic and very vague and very general, but they expect you as the engineer, right, to work with them to trim it down to maybe the streaming part where the user types in something, the request gets into the backend, some videos are obtained and brought to the front end in the form of maybe packets or using TCP or something, right? Then there's the last part, which is a very specific thing, right? So for instance, design a system, a URL shortening, system. That is pretty specific, right? Where let's say, like those who have seen, for instance, I'll Zoom URL, it's a very long thing, right? It's like Zoom dot US dot English blah, 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 blah. It's a very long thing. Dot tech elevate something, something, something. But this is so long, right? So they want to shorten this and we can use maybe tiny URL or maybe bits.ly, right? So like basically design these systems, right? Which are more specific than the first ones we talked about. Because you realize you're focusing on just one specific functionality, the URL shortening, right? So you can get, any of these kind of systems in the system design, but at least at the college level / new grad or intern, it shouldn't be any scary to you. If you get either of these three, it shouldn't be scary to you at all. You just learn one, you can literally always apply it. You can literally extend it because they don't expect so much specific detail from you, like amount of data being transferred, the kilobyte, the megabytes, the bandwidth, and those things. You don't need to bother with any of those things. Okay, so now let's talk on one system. Basically the dynamic recommendation system. Dynamic recommendation system. So I'm going to kind of make this session kind of a blend between presentation and also how an interview works, right? Like some of our previous sessions. So, okay. So the interview asks you to design a dynamic recommendation system. The first thing you do is you try to clarify what a dynamic recommendation system is, right? So you clarify, right? Clarify. So they'll probably give you how it works, right? Like maybe when you open Netflix, you don't see just, some 3 movies showing you. You don't even see an empty page, right? An empty page, let's say you're using Netflix web, right? The one on your computer. You don't see an empty page or something. Instead, you get a couple of movies, usually in the form of tiles, presented to you, right? That's basically the dynamic recommendation system. So once you have clarified it, the next thing I usually ask people to think about is data, right? What do you think is going to the data that is going to influence their system, right? So for instance, if I ask you to design, let's say the first big project I talked about, the first big system I talked about, where you want to have a call at some restaurant, you want to have a call in New York, you don't have any place to have your calls. You want to use a restaurant, but the restaurants are sometimes noisy, sometimes cluttered, some people are fighting at the club and everything. The data, one data you may need is what times the restaurants open, which restaurants are quiet in the afternoon, which restaurants are, data is very important. The same thing for systems, right? For this question, I want to design a dynamic recommendation system. So what kind of data do I need? What kind of data will serve as the fuel for my recommendation system, right? Can anyone give me some data that can serve as fuel for your recommendation system? Anyone?
The
Anyone?
likes.
What?
The genres.
Good. So you consider things like genres, right? You consider things like Simon, what did you say?
I was saying like likes or dislikes.
Exactly. So let's say user interactions, right? And we can consider that into like likes, right? So these are data that can fuel the recommendation system. What else?
How long the person watches the
right?
video.
How long people watch the video, right? So like let's say duration watched. Yes, what else? What else? You don't need to name all of them currently, right? You can just give 3 and then you move on. But as you continue to refine this design, more things come up, right? And again, If it were that easy, Netflix wouldn't have hundreds of engineers working on things like this or tens of engineers, right? But I want you to at least, work on a piece you can do it, right? What else can we consider? So I'd be like, okay, recommendation system, maybe I'll consider geographical region, right? Maybe geographical location, right? And this is something that may not occur to you instantly. That is fine. With time, you can, pick up, right? And right now, I'm just thinking again, I'm like, okay, I'll also consider age, right? Because some movies have age restrictions, right? Right. For some, you see like 16 plus. I beg, if you have Netflix then coming up, please go and get somebody's Netflix and watch Netflix for like one day and know how the features are. Not that you get that. Sometimes you get a player game. We'll probably look at that before you go today. So, okay, I got these 3 points. I'm like, okay, so my system is probably going to need some data that we can use to make our decisions. So let's say the age of the person, the likes, the duration watched, and geographical region. So I'm like, okay, I think I'm going to keep those now. So I'm kind of like doing like, if I'm doing an interview, a specific like, interview kind of thing. So next thing I'll be like, okay, so at a high level, my system is going to look something like this. I'm going to have the user here. I'm just showing exactly how you can go through the same design interview, right? You can just use this template as at least for internship and new guy. I'll be like, okay, I'm going to have something like this. I'm going to assume this is my client, right? I've explained to you what a client is from a previous session. And I'm going to have something like, a server, right? Let's put this box here as our server. If you don't know what these are, don't worry, I'll explain right now. So I'm going to like my clients is basically, a browser. So let's say we have a browser here that is watching, Netflix, right? So we're going to use Netflix web. Somebody basically watching Netflix here. And I'm going to have my server here. And then they're going to be making requests to each other, right? So this client opens the browser, wants to watch the video, the request is made to the server. And then what do we have now? I'm going to have a database here. Let me put some database here. I'm going to put some database here like this as a container here. I'm going to call this DB, right? And then the server is going to speak with the database. So this is a very high level design of many systems. You have a client, you have a server, and then you have a database system. Now, once you have this very skeleton thing here, then you begin to now, make it more specific to drill deeper down, right? Now, let's come to our database. You can start working from behind. Let's come to our database. You can start working from behind, right? You can also start working from front. It doesn't matter, right? So I'm like, okay, so I'm going to take my database for now. I'm intentionally working from behind. So take my database from now. I'm like, okay, so here, what kind of data will my system need to store to, have this functionality? So one thing that can influence what your data needs to store is going to be these things you labeled here, right? These things you mentioned here. Like you mentioned genres, you mentioned interactions, like the age of the user, the likes of the user, the duration match, and all those things, right? You can be like, so for my database, I'm going to store some information about the user. So the database I will store is going to be the user DB, right? The user database, information about the user. You can store things like maybe the user ID. Usually every entry in your database should have an ID. A user ID, the age of the user, the location of the user. I'll be like, oh, also the language of the user, right? Because if some movie is strictly in Chinese and I don't have English subtitles, maybe they just speaks English, there's no need for me to recommend it to them, right? You see how I'm exploring things as I go through, as I go by it, right? I didn't mention language here, but now I just push in language. Does that make don't need to list every single thing, right? Just list a couple of things. And I'm going to also have something about, let's say, the movies, all right? The movies or the shows. Let's just call it movies DB. And for that movies DB, I'm going to have, let's say, how many likes, we can even call it likes DB or whatever, but let's just make it movie DB and how many likes the movie has. Let's say that's like have a dislikes feature. You're like, I'm not really sure, but let's just add a dislikes field, like that. Let's add a language in which the movie is also in, and so on and so forth. And just list out a few things you have here, just like that, right? And then you can have another database, but for now, let's keep with these two, right? So you're going to have two databases. I had just made one database diagram here. You can make two if you want, right? It doesn't change anything because you're detailing it down here. So you're going to be a database to store the user information. I want to store the information for the movies, right? And then you can be like, so given there's a structure of my data, what kind of database do I want to use to store this data? Now, if you remember, our session years ago, we talked about types of databases, right? You can use a relational or non-relational database. Looking at this, you can be like, here, given that the users kind of have a specific schema, right? Like users have, user ID, age, location, language. Like every user kind of has these fields, right? It's constant across them. I think I like to use a relational database, which represents data in the form of tables. Does that make sense? Did you see I just justified one way I justified my use of a relational database like Postgres or those databases that store data in the form of tables? Is because my entries kind of have my users have kind of like a fixed schema, right? If it were the case, that some users have only 3 fields, some users have only 5 fields, some users have only 2 fields. Like if the schema, right, this is basically the schema, so we call the schema, right? Like the kind of data that you store about the user. If they varied, then a non-relational would have been a good thing, like MongoDB. But that's still in form of comments. But here's like every user has kind of the same thing. If you're creating a user account in Netflix, like we all fill the same form. That's what we need to think about. We fill the same form. If you're logging in, we use the same thing. If we open the page, we'll see a profile picture, kind of the data is kind of like the same for every user, right? So then relational database is good for that. But that's not the only reason why you may want to use a relational database. That's the reason I may want to use a relational database is joining. I explained that to you when we had that previous session. So look at the pros of a relational database and see if any of them translate to this. I just give you 2 reasons that we're going to use this. When it comes to the movies database too, use a similar justification. I think I would like to store that in I also like to use a relational database for that because the information about the movie, so it's also movie name, also with the movie ID, right? Movie ID, like this. Now, if you can see here, I'm not really storing the movie itself in the database. We explained it when we did previously. Many interviewees, like college students, will be like, we're going to store the movie in the database and everything. But no, this is where you come in as a technical person, right? Where that's when we mention something, you can use an object storage, right? So what did we say about object storage? Anyone, if you remember? So here, we are not going to store an actual movie here. We're going to do something like that. We are going to instead store the URL of the movie, right? Let's just call it URL, movie URL, right? So these data are going to be stored in another relational database, right? And we're going to actually store the actual movie in an object storage. So for instance, you don't need to give examples, but like Amazon's S3, there are a couple of object storage, right? Where you can store like actual media, and then you get the link to the media, and then you can store that link as a URL here, right? So it'd be like, then I'm going to use an object storage. You can then put some other cylinder here, some cylinder somewhere. You're like, okay, that's going to be my object storage. And then these are going to just communicate, right? They're just going to communicate like so. And this is maybe my movies DB. Now you can be more granular with this by, for instance, you can split this table. I'm just trying to, just make things at a higher level and you can read the documents. I think the documents actually split things, make them. So this one you can actually have a likes table. You can actually have a likes table. Where a likes table is going to be very simple. We're going to have it has an ID. Every entry has an ID. We're going to have the movie ID. Then we're going to have the number of likes, right? Number of likes. So, but see, it has just 3 entries. So you want to get the number of likes of a movie, all you have to do is you have to perform a join, right? We explained this. You have to just perform a join with the movies database and the likes database. So how does a join work? A join takes 2 tables. Then you specify a join column. Looks for the common column between them. So this is the movie ID column, the movie ID column. Then it will merge both of them together. So based on the movie ID, you can then follow that path to get to the number of likes, right? But if just one field or something like this, you can just make it a field here, like number of likes here, instead of creating a whole new database for it. That's just something I'm telling you. If you design a system and the table you want to create just contains like one field you need like this, like number of likes, you just make it just a field in that main database. Does that make sense? That main table. Does that make sense?
Yes.
Okay.
Yes, that makes sense.
Okay, let's move on then. So we have that. And then, so you're almost kind of like done with your database, you're not focusing too much on the database kind of things. Here you have shown that you know what a relational database is, what a non-relational database is. You explain how, your schema is going to look like, some data you need to store, usually like these data, duration, geographical region, we have all of them written here and so on and so forth. Usually they don't use age, they use date of birth, right? And they just compute it. But, it's kind of like same thing. If I guess the high level what you're trying to say, then I'm going to store, add some spice. I'm going to store the movie. Maybe the movies can be like, let's assume Netflix is storing their movies in an object storage somewhere, and they just store the URL here. You don't know for sure because you don't work on Netflix, right? You didn't be doing this interview in the first place, and then so on and so forth. So some people can have a database server, which for fun, I just ignore that. So we're like, okay, so we are done with this first part. Let's come here. So as you can see, we've gone through this part of our design. And now we are coming to the server part, right? The server part. Now, I explained to you that a server is just a computer. A server is just a computer somewhere in some warehouse that is doing a job for you. Like I'm using my laptop right now. My laptop will serve as a server, right? If I'm running my websites locally, that is a server. It's not any scary thing what a server is. Usually, how servers usually work is that if you go to, let's say, somewhere in California or somewhere in South Africa, I think Microsoft, for instance, they have a couple of data centers in Africa. I think they have it in South Africa. Other places, they probably should bring it to Ghana soon or Nigeria. So this is how it looks like. When you go to these data centers, they're like big rooms, like warehouses, like very big rooms. And they have these things they're called racks, right? This is how a server actually looks like. So you go to this big room and they have these things called racks. And in the racks, they actually have these I don't know if you have seen those flat system units. They have very small form factor, like they are very flat, right? Like horizontal. But those are not like the kind of how the service looks like, but like the shape is like that. So they have these very flat things inside them. These very flat things are what we call servers, but they're basically computers. They have RAM, like a computer, they have storage like a computer. Some of them have very high CPUs, GPUs, and everything, but that's basically what a server is. But I think of a server as just some computer somewhere. So now, let's say this is our server. So now the question then becomes, don't forget, you're designing a recommendation system, right? What does this server do, right? So the server usually holds, it's kind of like the core of the system you're designing, right? So I'm trying to design a recommendation system. So look at something here. The recommendation system is being fueled by this data. By this data, let's change color. By this data, right? Now, whatever happens to this data, whatever we're going to use this data for, is what is going to be centralized in this middle here at this server region. This data is basically being transferred from the client. It's going to be stored in your database. That's transfer, between that transfer and that stored in the database is the server here. What is the server going to use the data for? Well, this middle part is going to take the data, right? And then it's going to do something to it, right? And that something to it is then eventually going to generate your movies that will be sent back to you. So let's see what I'm talking about here. Let's change colors. Let's use red. So we are still on this central part here. Don't lose focus. We are still on this central part here, this server part here. At the central part here, I'm going to have this. So it's just this big box here. You can have multiple of them here. I'm going to have one part there. I'm going to call it let's call it server one. Let's just call it server one for now. This server one. What this server one is going to do is that it's going to take so when you reload your page, right? I'll come to the client side. Let's even come there. If you reload your page now as Netflix, it comes here, it wants recommendations, right? Then it has this server part. This server part will then go to the database. Then we'll get the information from you after you logged in, right? Or maybe if it doesn't have the data already, just go into the database, get the information. Now that information comes to the server. Now, what is the server going to do with this information? That server that is going to do something with this information, let's call it server one. What will it do? It will take this data that it has, all this data that we have here, which are going to use to make a decision. Then we'll use it in some way to generate recommendations for you. So let's see what it can do. One is that it can be hard-coded, right? It can be like, hey, if age is this, moved by this, if age is moved by this, blah, 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 blah. But usually recommendations are use machine learning algorithms, right? You can be like, this is actually a server that is going to run an ML algorithm, a machine learning algorithm. See, you don't need to be an ML expert to say this. Just be like, your server takes, so you're going to have a server here that runs a machine learning algorithm. What it does is it just takes this data, this information here, and based on that data, suggests movies that the user can watch. That is literally it. This your server here is just a laptop that runs machine learning algorithm. If for a server that usually runs machine learning algorithm, there's some information about the server. If you want to be specific, which I think it should be. One, it is GPU, it uses a GPU. It's GPU intensive. This is why NVIDIA is $1 trillion company, GPUs. Because machine learning algorithms use a lot of power, right? They use a lot of compute and everything. And GPUs are really best for that, not CPUs, right? So you can just be like, so I'm going to have a server here that basically runs machine learning algorithm. And this server is going to be very GPU intensive due to the high workload of the machine learning algorithms. Does that make sense? Just throw those keywords in and run away, right? I tell people, you don't know things in detail, mention them and run away, right? Don't detail so much into it. And so it takes the data and then it just use it to generate the recommendations. And after it's generated the recommendations, it then sends it back. So let's call this server 0. So you see server 0 and server 1 are working, right? They're working together. So server 0 makes the data, it gets it from here, then it brings it to your server 1. Server 1 is the one that contains the machine learning algorithms and everything. It then generates the recommendations, then brings it back to this guy, to server 0. Then server 0 will then take it from there. Does the flow make sense to everyone? This guy logs in, everything. This guy gets the information from the database. Database brings the information. This guy takes it to the machine learning server. Machine learning server uses the data to generate the recommendation, to make some predictions, generate the recommendations, be like, okay, movies with the theme action, movies with the theme trailer, movies with this, movies with English and everything, right? You know how machine learning works, right? Then takes the recommendation, brings it back to this guy. Then this guy here has access to the actual movies or the movies object storage, right? Then this guy will then sorry, I need to move this down. Yeah, so then this guy here, this server guy here is kind of like the brain, right? We'll then select the actual movies can you see it? Okay. Then this guy here will then work on the actual movies that should be selected, right? Or maybe go make the actual movie picks. Then when he gets the response, look at this line I have here. Sorry, my pencil's behaving. This line I have here is hardly the case. The first time you brought this line here, it was just an abstraction, just did the skeleton thing. But usually when the server gets the data, it doesn't bring it to this guy straight away. Instead, we mentioned what we call a CDN the last time and caches. We mentioned caches the last time. Instead of bringing it outright like this, he doesn't do that. He instead, what's happening here? Sorry, my pencil is misbehaving. What's this? Sorry, my pencil just, it just automatically switches. So when this guy gets the response, instead of bringing it straight here, it doesn't do that. Instead, it takes the response and stores it in some cache here. We talked about cache the last time. When it brings it to the cache here, then from the cache, the data is then sent to this guy, to the client. Why are we caching it? So that if the user, let's say, refreshes it again, for instance, we don't need to do all this long processing again, here, then here, then here, and here, and so on. No, we can literally just pick the data from our cache and bring it to the user. Now note, it's a dynamic recommendation system. So that means that if you cache the data, you can't always return it for the whole week, right? When any of these variables changes significantly based on your algorithm, you can invalidate the data in this cache. Or you can set the cache to maybe expire after maybe 10 seconds, right? That means that, hey, after 10 seconds, please don't go to the cache, right? Make this whole process again. Does that make sense at a very high level, how our recommendation system is working? This at a very high level, and very typically, if you present this thing, you're literally done. Like, it's going to work for you. So we are done with the server part. Our server part has the logic. Here you can see we use two servers. This is one server that the client speaks to, right? The client speaks to this guy. And then there's this server that actually has the brain of the recommendation system, right? And the brain of it is going to use a machine learning algorithm. And this server, the server is a computer just like a laptop, is GPU intensive, right? Because it's running a machine learning algorithm. Now, you can detail what a machine learning algorithm is going to be like. It's going to be like, okay, so it's going to take, machine learning algorithm usually does something called, that's what we call the input and the output. The input is something we call features, right? Features. So features are basically the data that you use, that a machine learning algorithm uses to generate an output. So here, these are my features: age, likes, duration, what geographical region. Basically, those things you specified here, right? Those things you need to use to make the decision. That's what we call features, right? There's another feature you can think about. Another thing the machine learning algorithm can use can be like, I have access to the geographical region, right? To the geographical region of the user. What if I also consider movies that the people in those geographical region are watching? So for instance, I'm in Ghana, right? And then, I just relocated to Ghana. And these are all things you should mention in the interview, right? Like if you're designing systems, you're open-minded. You mention these things externally, like you think, bro, that's how we don't use one engineer to design this system. There are many engineers so that they can all brainstorm and think wide. You're like, I don't think my system can use this. If I'm, let's say, in New York, or if you're in Abuja, and consider movies that the people in Abuja are watching, or the people that are being recommended to them. And I can also include that in my recommendation system. So my algorithm is also going to use, you can just put a plus here. It's going to use, movies being watched by other people, movies watched by others, right? And then you can also use that to make the recommendation system. The other thing, you want to make your recommendation system as robust as possible, right? Like very robust. So that's why this data part is very important. The data you think your system is going to need. But let's go by it again at a high level. I'm just going to, actually, before that, let's come to the client's portion. That's something we usually leave out. Please don't leave it out. When you do the system design, please don't leave out the client's portion. So it comes to the client's portion here. I'm like, okay, so for my clients, where is it? My client's portion, be like, okay, so my next is going to be the browser Netflix. Can actually talk about the UI, right? Can be like, okay, so there we actually have a very responsive website, and yes, we built it using React or something. We're going to have the data being shown in the form of tiles, right? So when the data comes here, when it gets brought here, it's going to be parsed nicely and then displayed, let's say in the form of tiles or something, whatever, maybe cards, and so on and so forth. And for every data that gets brought in, you can describe how the data format looks like, right? So let's say when the recommendation comes, sorry, I don't have Netflix subscription, I couldn't afford. It has the title. It usually has like, is it like a trailer? I don't even know how it looks like. So you can like the data that is brought here that the server actually ends up bringing. What else does it have? It has what duration, right? Usually it has a short description, right? I bet people don't know because they also don't have Netflix. just usually a very standard movie thing, what the thing that shows, right? And so these styles are basically going to contain these things. So basically, just describe the payload, right? The data that is being brought here and at a high level, and you're literally done, right? So let's go by it again. How the recommendation system works. So the user here, I'm now doing from front to back. The user refreshes or they log in. Once they log in, the username and password are being sent authenticated. That's not your focus. You're just doing the recommendation system, right? So just keep that part. And once they log in, the request is then being sent to our server here. And this our server, now, notice that the user has logged in, it needs to send some recommendations to it. But the core of our recommendation algorithm is actually in this machine learning server here, which is very GPU intensive. So it needs some data for machine learning algorithm needs some data to generate, the recommendations that this server can then use to eventually send, the movie recommendations to the user. The data we need include the age of the user, how many likes or dislikes a certain movie has, or the likes or dislikes of that user. To maybe the user also previously disliked some movie, so then you want to decrease the chance to select similar movies to them, right? So you can, even with that means I can modify my movie database and add similar to, right? Or something like that, right? So then with that, so we can get that data from our database here, right? We can get it from our database here. So once our database gives this server 0, our database, we then come here, give all that, feed all that data into a machine learning algorithm, and then it's going to generate, its predictions, its suggestions, which then be sent to our server 0. Based on that, server 0 can now contact the object storage that stores our movies, and then obtain the data from there, and then we'll then cache it. After caching it, the data is then now sent to our clients, right? The next time our client wants to, we can set a time to live. We call it TTL. TTL, that's time to live. For the data in our cache, we can set the time to maybe 10 seconds, right? That means that for 10 seconds, anytime the user reloads the page or goes back to the home page, we should just, return these same recommendations. We can make it 5 seconds if any of these, variables, if any of these features change, right? Just like that. That makes sense. So now I've mainly talked about these components. Next, I'm going to focus about these network calls, these arrows you see here. But that's everyone gets the brain behind these components, how this works, how that works, and how that also works. Database, we talked about relational, non-relational. We just mentioned why you want to choose a relational, why you want to choose non-relational. Please don't focus on like 10 minutes talking about relational, non-relational. I know some people just try to don't. You design the system, you're not teaching a distributed data or a system design class. No. Just be like, why do you need this? Fixed schema, mention I'm going to choose this. This is going to be the structure of my data. Please always align the structure of the schema of your data. Sometimes people will be like, if you have time, you're bored, this is going to be an int. It's not necessary, to be honest. Like, I've done it before though. But it's going to be an int. Basically, what I'm going to say string, just skip it, right? And so here we talked about types of database. Here we talked about how your server, this one is just a black box. So this server here actually contains, if you're designing a game, for instance, like a game system, this can actually contain the logic of the game. This server can contain the logic of the game, and so on and so forth, right? The game logic, because game is code, right? And so on. And you can have multiple servers. That's something I split it here. This is the machine learning server, and this is actually the server that is a client speaks to. That speaks to the machine learning server, then the recommendation, and so on and so forth. Now let's go to the network calls, right? Are we good with the object components? Are we good with these parts? Are we good with these parts? Are we good?
Yeah, I just have a general question.
Yeah.
So like usually what's the structure of these interviews and where will you be working? Will it all be in the IDE or will they give you like a
we usually have
canvas for you to record this?
It's like a Google Doc. It's like there's a name for it. They usually like a whiteboard space like this. And usually you just like design things like you can usually create shapes, or you can just type, right? Like if you can't, you can just be like, so I have my client here. All right. So you like the style. I tell people, you just do a very skeleton high level. Like just like we did it. Like we have a client here, we're gonna have a server here, we're gonna have a database, right? Then it can be like, okay, let me take it one after the other. So a client is just going to be, this. If you can't draw, let's assume we can't draw. Can you just put some box there? So let's say the browser and our server. For now, let's leave the server as a black box and let's come to do the database. So the data we're going to store are going to have some data on the user, some data on, let's say, the movies. Let me use games, right? We're going to have some information about. Okay, so we're going to have so a game too. You need the information of the user, right? Because they track the user. Because some users should not be able to play, right, based on their age. Care about those social things, like the age of the person. That's something that will distinguish you from a good engineer and an average engineer, right? If you think about the social aspect of your technology, right? The age of the user, where they are, the language they speak, and all those things. Then the game too can have the game too can have. So here for the game, you can have different things about the game. Games have graphics and everything. You don't need to store the graphics here. Graphics can be stored in an object storage, right? And then so on and so forth. If look here, if the data, let's talk about the network calls. There are a couple of things I want to also mention. I want to put in these pinches, these extra spices that will also set you apart. So let's come here now. It's a bit too cluttered now, but yeah. So let's consider network calls. So here, so let's write API here, APIs. So when this client, can you see this green thing I'm moving? Can you see this green thing I'm moving? Can we see this green thing?
Yeah.
Okay. So when a client first logs in, right, this thing here, this REC here is actually a network call, right? It's a network call. You don't see message queues or anything. It's just a network calls. So it makes a network calls hits at some endpoints, right? It's doing some endpoints. So you can just be like, so you're going to have an endpoint for recommendation system. You're going to have it, just call it /API, or just call it /API, /API/ maybe v1/ maybe recommendation, something. So maybe get recommendation or something. No, you just use some good name for it. And it's just a get request, right? It's a get request. Because it's a get request. It's not like a push request. Like you don't fill in the form to submit to the backend to then get the recommendation submitted to you. It's just a get request, right? So just write gets there. And then that's just an HTTP request, right? It's just a network request, right? And the data it contains, here is a get request. You don't send some data to the backend. Like you don't send some data. You don't send your age. See, these are not things you are sending. Like you don't send like here. See, you're not sending your user, you're not sending your age, you're not sending your location, you're not sending your language, you're not sending them manually, right? You're not actually doing that. Instead, a network can have a header, and that header or a token that goes along with it. So you can be like the user ID, so a header or a token. That token may contain the user ID. Please, if you don't mention this part, it's fine. But if you just want the specific, you can do that. That contains the user ID, right? Or some other data. But it's just a GET request. It doesn't contain some JSON payload or anything like that. No. And then, so that's just this forward arrow, right? It's just a GET request that it just send in there. And then these are actually server network calls. They can be message queues. They can be whatever. You don't need to focus on them because this is just this guy just speaking with a database server, right? You can just skip that part here and so on and so forth. The other crucial thing is from the server. The main important part is this part here. This part here, we've talked about the going. Now the coming. Usually, when you are bringing a video, look, when I usually bring in, at least in Amazon Prime, usually when you hover over the tile, that recommended movie tile, it kind of plays a bit. I don't know if Netflix does the same thing. Even YouTube, right? It plays a bit. I don't know if you've seen it. It plays a bit. So usually, what happens is that when that server is bringing the data back to the client, you can see how I'm ignoring the cache. You can see how I'm ignoring the cache here. Ignore it. If you're explaining something and you think these intermediate, we call these things proxies. If you think these things you're putting in the middle here is going to complicate your thing, right? Put them there. Now they know you know what the cache is. But if you're talking about the network cost and everything, you think it's going to complicate it, just ignore it. See, you don't need to always be saying on things. They know you know what that it was already mentioned it. You can just go on. So now assume it's just to and fro, right? So you can be like, so when the server is bringing the data back to the clients, right? It doesn't bring the whole movie, right? Because that is going to be very slow. It can't load the whole 2 hours movie and bring it. It's going to be very, very super slow. They bring that in the form of packets. They bring bits of it. So you can see even when you load the YouTube video, sometimes it loads to some 5 seconds, then it continues to load to expand, continues to load to expand, continues to load to expand. I don't know if you've seen that thing. Like it starts out as let's say gray, then it gets no color, there may be some gray thing, then the gray thing continues to expand. Maybe now it hasn't, but like many decades ago when I was alive, many centuries ago, it used to be expanding, right? Like if you click outside that expanded region, it takes a bit more time for it to get there. Do you remember that thing? I don't know if you've seen that, you've made observation.
Yeah.
It's because the movies don't get to load, like they don't wait to load the full 2 hours. That's going to be very latent. The latency is going to be high. So it can be like, so it loads the movie in the form of, it loads the data in the form of packets, right? So then the packets then get sent. It just loads it in packets. So that first packet can be like 5 seconds or so and so. And basically it uses UDP. UDP, I think it's UDP. It's what they use, right? And it'll be like, so that's basically it's UDP, right? That's the network protocol. I'm just saying it just for it to be fancy, right? It can be like, so when the server brings the movie, so when it brings the recommendation system, it's going to bring, let's say, the first 5 seconds of the movie in the form of a packet via UDP. Just mention it and run away. You are done. You see how I said it. So the recommended movies that comes has, let's say, the first 10 seconds of a movie that is sent, in the form of a packet, and it's just across UDP. Once you mention that, Charmaine, don't go and breathe. Run to the next thing and move on. Right? See, that's the thing. If you talk, see, I'm speaking fluent. People think I know what I'm saying, but I probably don't. And then you move on and then you go, right? So that's just the network thing. It's just UDP. Movies are sent in the form of packets. I'm not listening because you may get a different system, but with these terminologies in mind, you can just throw them in here and there. But there are a couple of things in the chat. Let me open and see. The API part. Someone asked API parts. Did I mention API part? Oh yeah. Oh, that's what I'm talking about now, right? Let's use Excalidraw. Okay. You can easily draw shapes. Yeah. Yes, sessions and tokens. Okay, let's talk about that. But can I take the networks again? Okay, yeah, let's do that again. So the network calls are basically, these arrows I have here, right? Sometimes it's not a network call. Sometimes we use something called message queues. But message queues are usually used at the backside, right? At the server side. Like this server speaking with this database server, they usually can use like a message queue. Where let me talk about message queue. Talk about message queue. Probably don't need to know it, but basically, this is how network calls work, right? If I make a network call, you send the client or one component sends a message to another component. Then also this is also a server. It's a database server. I just call it as DB, but it's a database server. It's also like database are not. We don't have a database like cylinder somewhere. It's also a computer. It just runs a database software, right? Software for the database. So for a network call, something like HTTP request, there's a request and there's a response. But send the request, you need the address of the server, right? That the client sends to a server. Then the client needs to know the server's address. And then the server also needs to know the client's address to return it back to them. But not all communication are like this in systems. Sometimes it's like this. Sometimes it's something called message queues. So for instance, this is component A and this is component B, right? Component A puts their request in a queue. You remember a queue, what a queue is? It's the application of data structures and algorithms. So it has the first request, let's call request A. Let's say request 1. You need to put request 1 in the queue like this. Now, when server B is ready to work, server B will then come to the queue and within the queue, we'll take the first request here, request 1. And then to bring request 1 to come and process request 1. There's another queue here. When it's done processing request 1, to come and put it in here as response 1, right? So this I can queue as many messages as possible. There's an advantage to this. Look at the advantage to this. Let's say request 1, request 2, request 3. Notice a queue is first in, first out. Let's assume you have copies of B. That's something we talk about soon when we get to scalability. What I'm discussing now is called the functional components. Functional components means the thing that functions, right? Like the use case, the actual use of your thing, of your system, right? That's called functional components. So you may have many copies of server B, right? Server B right here. So with a message queue, right? This guy sends the request only to the requests are being queued in this queue. So, but there are many copies of server B here. So the first server B can pick request 1. This guy can pick request 2. This guy can pick request 3. This guy can pick request 4. So you can see it's very scalable, right? Like it makes things go super fast, right? But these guys can all come pick to the queues. This guy doesn't need to make requests to like all these guys independently. He doesn't need to. All he needs to do, and it doesn't even have to be one client. It can be like multiple clients. They all put the data in the queue, and these guys can just come pick data in the queue, which is super cool. There's more to it, right? Another cool thing about message queues is this. Like, if this guy, assume this guy came to pick the request, right? And this guy died before it could execute the request, right? So each time a server comes to pick the request from the message queue will hide, let's change it, will hide this request and be like, hey, this guy has been picked, but it will hide it for, let's say, 5 seconds. Again, time to live or something, 5 seconds. After 5 seconds, if this response has not been put here, right, then it should be like, oh, maybe this guy was supposed to use 5 seconds to process this request 1, but 5 seconds have elapsed and we've seen nothing. So if this guy died or crashed, computers can crash, servers can crash while doing it, then it will then, bring it back to life. So then bring it back to life. So to basically cancel it, to be like, this guy is still active, and then this guy can now go pick it and continue. So you see the cool thing about message queue. So this guy, the client didn't need to make the request again, right? It didn't need to make the request again, because if it were an actual network, like the original HTTP thing we've been doing, if after that 5 seconds, that would look like this, A and B. After 5 seconds, if this guy has not got the response yet, this guy has to make the request again. But with a message queue, this guy doesn't need to even make the request again, because this message queue guy is handling it, right? It's kind of bringing this thing back to life and so on and so forth. So that's a message queue. We're not using a message queue here. We're just doing an actual
Cornelo,
yeah.
Is the message queue the same as load balancers or what? Because it looks
Oh no,
like
it's not the same. It's actually not the same. Don't worry. So this is the message. It's just an extra thing you want to know. Just keep in your mind. Now I'll talk about load balancers and gateways very soon. It's just going to be this is the functional. I'm going to now go to the non-functional part. I talk about scalability. That is the last part you talk about in the interview. You talk about the functional parts, right? If the system doesn't function, why do you want it to scale in the first place? Scale simply means now there are 10 people using your system. Now there are 1 million people using it, right? Now here using just one server to handle everything for the 10 people, that was fine. But 1 million people, the server will crash, right? Because the load is too much. So many people are making a request to it. Therefore, you need to scale it. That's a non-functional thing, right? Now, if it doesn't work for 10, why do you need to care about scalability? So you talk about the functional part first and then the non-functional part. On that note, let's skip to the non-functional part. As I said, you have this diagram, is fine. The non-functional part can just talk through it. You don't even need to diagram anything, to be honest, right? Talking is more important. So you can be like, so now, actually, the truth is, in some interviews, they will be like, assume one client. So they will say, when they say assume one client, don't bother with even load balances and all those things because they said one client, right? That means that the system is a very simple system. You don't want to stress you, right? Okay, but let's still talk about it. So non-functional components. So non-functional goes beyond just scalability. There's a couple more. There's even security, right? So for instance, somebody mentioned we talked about tokens, right? Tokens, like when you sign into a website, they give you a token, right? That's token-based authentication. The token is like some gibberish, and so when you log in at first, it gets you a token. Please note all these because you may get a system that involves login or something like that, right? When you log into a system, right? So if you want to log in, if you're a client like this, and you log in, so you complete the username and password field, it comes here, this is your server. The server then authenticates it, at least a server, just like this server. The server then, maybe, takes the data. Then to go and check the database here, again, you see the same system designer. Come and check the database. They user with this name, let's say Con2. Be like, yeah, this user with Con2. Be like, okay, give me Con2's password. Then the Con2's password will come from this database. Then, so you give the user a password here when you were logging in. Then database also gives the password, like this is the actual password for Con2. Then the server, again, will compare these two passwords. That's how authentication works. Can we all see the flow? Like when you're signing in, you give it the username and the password. Then take the username to come and check the database. It'd be like, hey, database, give me the password for the user with this username, right? They're like, okay, this is the password for the user with this username. If there's no username like that, it tells you username not found or user does not exist. But if there's a username, it brings the server the password for the username that was stored when the account was created. Then the server here has the logic to just compare those two passwords, right? Be like, okay, this is a password you gave, this is a password in the database. Are they the same thing? Yeah, it is the same thing. Then it will send you successfully logged in or some homepage, 200. The request was okay, right? If either the username or the password was wrong, it tells you username or password. Note, you never sign in and say username is incorrect or password is incorrect. No, because of security reasons. If I sign in, if I give you a username and a password, and let's say only the password is wrong, and you tell me password is wrong, that means you have told me the username is correct. So a hacker can exploit that. That's a security feature you should know if you're designing a system, all right? Instead, they tell you username or password. Meanwhile, it could just be one that is correct or one that is incorrect. Does that make sense? Does that make sense to everyone? Why usually see username or password? It doesn't just tell you username or just password, right? It's security reasons. But when it validates one for you and you're a hacker, you can find a way around the other one, right? Yeah. And so you see, we just designed an authentication system. Literally, that's the flow. Literally, database, server, user, blah, 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 blah. And so on and so forth, right? And here, when you sign in, right, when you successfully log in, it then sends you some data here. It sends you a 200, okay, that was a successful login. It also send you a home page, right? But also it sends you a token. The reason why it sends you a token is this. The token is sent so that in case you make any other request in future, right, it still needs to authenticate, okay, this is Con2, trying to get these movies. It doesn't need to be like login again to authenticate you. Instead, it uses that tokens are usually passed through cookies or the header, right? And then, so that token is really a gibberish. So when you make a request in the future again, that token is somewhere in the request, which you don't have to manually put it in, it's in the header. Then if you take that token, again, usually the token contains your user ID or something, right? Put it a subject and, but yeah, so you take the token, then to validate the token again. Is this token valid? That means, yes, the token is valid. That means they've signed in and it's, yes, it's them. And like, okay, now give me the movies and let me send it back to them. That's how it works, authentication, right? So any request you send in future, It then looks at that request, goes with the token, looks at the token, then be like, okay, this token is valid. Token is nothing scary, just some gibberish, right? But it's valid gibberish. Like, okay, this token is valid. Okay, that means Contu is really signed in. Give me the data they want. Let me take it back to them. Tokens have an expiry date. You can make your token short-lived. That means that, so you can see that you sign into your Google account, it's valid for, let's say, a week. So after that week, each time you open your Gmail on your phone or in the browser, you don't need to log in again, right? But after, let's say, 1 week, it expires, right? And then it's like signing again. You can also have a refresh token where, so far as you continue to sign in less than 3 days, it will always get you a new token and so on and so forth. So that's just, I'm just mentioning different parts of the system so that depending on the question you get, you can apply these things. Yeah, Blake, go for it.
Yeah, when you are going through these things, must you talk about any like frameworks or tools? So like maybe the data. Okay.
Yeah. You can be like, someone use a relational database like Postgres, MySQL or something, but you see, I didn't focus on this. I'm going to use a relational database like Postgres or MySQL or MySQL or something. If you know you want to show up, just mention to move on, right? Yeah, if you just make an analysis story that Amazon S3, you know, it can be like, you know, you've learned the thing, right? You can just mention it. Plus, you're fully student, just mention it and just have your way. That was like, so non-functional components. I was talking about security, right? The one way for security is hashing, right? Like if you are signing, if you're bringing authentication, somebody users have to sign in, or they have to log in. Maybe it's a game, they have to log in. You always have to hash the password, right? You hash the password. If they submit, let's say, my password is, I created an account 2 days ago. My password was somebody's middle name. Very scary middle name, not scary, cool. You hash the password, right? So that's if somebody, you know, hackers can intercept your request, right? If they intercept it, they see the gibberish, they don't even know what it means. So you hash the password, right? There's more to it, right? There's hashing. There's also HTTPS. So HTTP is a regular thing, but with HTTPS, the message gets secured. It's an additional form of security around your thing, right? HTTPS just wraps your thing again. The S it simply means secure or something. Yeah, security, secure, right? That's so you can be like, so we can make sure. So see, if you're talking about just be like this, to enforce security in a system, you're going to make sure that the requests are sent across HTTPS, so that it's more secure than HTTP. You're done. Mention that and move on, right? You mention it, you're gone. So our request has been going to be like, so our request are going to be made using HTTPS for higher security. And yeah, we're also going to make sure that, yeah, like just mention it and move on. You're not going to explain HTTPS there, to be honest. People even know what HTTPS is in detail. Yeah, Roberts, go on.
Oh, my question is, in the diagram that I drew above, is Contour the server? Like, what's the technical name
Which
for
one?
it?
The authentication one.
Yeah.
Oh no, Contour was the username, right? Was the username. Like they were signing in with a username, Contour, and a password. So when you sign in, you have a username, let's say Contour, and I'm like, so for the server, you can name your server, right? See, I call it server join server 1, but see, so this is, I call it the DB server, right? You can call this ML server, right? You can call this app server or web server, whatever you want to call it, right? You can call it a server, you can give it a service name. Does that make sense?
All right. Yeah, it makes sense.
You can call it like DB server, ML server, or app server, something. Like you want to specific names for them, right? Some people also use web server. Some let's say if you're playing a game, an online game, right? If you design an online game, that's another. I think I'll create a document for that for people. And last year, this also adds like online game and we're going to in a couple of things. So like, if I'm creating an online game, right, I can have two servers like this, right? This one server, this another server. This server is going to be my web server. This is going to be my app server. My app server is going to contain the logic of the game. See, I say if you don't know these things, just put a server that be like logic of the game. In other words, the code that produces the game, right? This can just be the web server that the client talks to. So this, I guess, it's be like, okay, I want to play this game, right? Maybe this guy can do the validation. So let's say, and then there's your database here. So this guy can speak with this database to validate it when you sign in and everything. So based on that, to be like, okay, you're signing in everything. Okay, now you speak with this if you want to play the game, get this data and then send it to you. There are other things, other processes you can consider, like gateways and load balancers and everything, but you don't need to. Honestly, you don't need to. Let's clean this. Let's come here. We are something non-functional, I bet. Let's come here. So I mentioned, so our requests are going to be made using HTTPS. Just through HTTPS and run away, as I said. See, run away. Speak confidently, run away. That was scalability. Hey, where is this thing from? Scalability is simply, now a system is from 10 users to 10 million users, right? So you want to do that. How to achieve scalability is pretty simple, right? You can scale up, scale out, whatever. See, this is what I mean. One way to achieve scalability is one, you can replicate your system, right? In other words, you can make copies of your system. So instead of one server, maybe you have like three or four of them, because Netflix is being used by people from all across the country, right? So you can make like 3 servers now where the people in Africa are hitting this server, the people in North America are hitting this server, Latin America are hitting this server, right? That's scalability. That is one. You also can scale your database, right? Now, depending on the database you scaled, you chose how you scale it may be a bit different, right? So for instance, if you choose a relational database, usually when you're scaling relational database, how we do that is that we scale them up, right? I think that's a word. That is, in other words, we use vertical scaling. So that means that so as I said, the database is also a computer like this. If it has let's say 10 gigabytes RAM, when you're scaling it, you actually increase the storage, let's say 20 or 30 gigabytes RAM. There's a reason for that. If it's just a non-relational database, usually when we scale it out. That means that we make copies of it. We talked about this in the previous video. Please watch it if you haven't, right? Depending on the database you choose, how you scale it may differ. It's easier to scale relational databases up. That is like vertical. So if it was like at first 20 gigabytes, now we scale it up to, let's say, 50 gigabytes. The reason is because of joining, right? Like because they're using tables, right? You want to perform the join, and the data is scattered across different databases or different servers. You have to, in a way, merge them first, and like the joining can be complicated, right? But you remember joining, you take the data in one table, take the data in one table, you join them together. If the data in that one table is scattered across different computers, when you perform a join with some other table, it's going to be a bit complicated, right? But if it's all in one table, it's easier to perform the join, right? But if it's non-relational does not do joining or does not really do joining. It has variations. Like MongoDB has a variation called lookup, but basically doesn't do this primitive joining, right? So for that, you don't care, right? The data is just, can be scattered across, right? And so we talked about this in that video, so please watch it if you haven't, right? So that's how you scale your databases. You don't need to scale a client. Like you don't need to make my laptop duplicate for me. I'm the client. I don't need duplicates of that. So that's how. So usually you do scalability by just duplicating the components, right? By just replicating it across. And that way you also achieve scalability is using a proxy here. A proxy is simply a component you put between a client and a server. That's a proxy. Forget about proxy. You can put something here called a load balancer, right? What does a load balancer do? So this is the non-functional part, right? As I talked about the actual thing, these are just some additives, right? So how that works is this. Let's say you have 10 users, right? I think we talked about load balancer too in the other video. And they're all trying to speak it. So now you've scaled it, you've replicated the service, right? They're doing the same thing. Unless your ML algorithms also somewhere here, then you have your databases also somewhere scattered across the world, like so. So now this guy is making a request. So actually, I'm going to call it a gateway. Here. Why is my phone vibrating? I don't know what's going on, but let's move on. So when these guys are all making requests, right? But see, there are so many of these guys here. First is, where do they go to, right? Where are these requests go to? This guy is making a request from Africa, they're making it maybe in Asia, they're making it in North America, in South America, and also in Europe and so on and everything. So usually you can have some components here, right? What that component does, let's even say all these are in Africa, even all these are in Africa, right? Africa is huge, amazing, fantastic. So when a request comes, this guy can be like, okay, I'll take this request to this guy. I'll take this request to this guy. I'll take this request to this guy, right? It's just balancing the load, right? Like, okay, these requests go to this guy. These requests go to this guy. These requests go to this guy. That's what a load balancer does. It just distributes the load balancer, right? So that the reason why we do that is because we don't want to see, if I put all the requests on this guy, it may be overloaded. And then, the request becomes slow and nobody wants to, they don't want to load the web page and sit there for 20 hours, right? That's what a load balancer does. It can distribute the load on a different service so that things just run smoothly. There's more to it. The load balancer can do more than this, right? It can actually do more than just this distribution. You can put in a lot of additional logic in your load balancer, to be honest. Load balancer itself can actually be a server on its own. Like if you're using a distributed system, this guy can be the coordinator. And this guy can be the worker nodes. The load balancer can also perform authentication for you. Can authenticate it. It can do a lot of things, but I don't care about it. You can just focus on the load balancing aspect of it, to be honest. Now, how does it balance the load? There are a lot of algorithms to use. One algorithm is what we call consistent hashing, which is kind of like the most popular, consistent hashing. I think I discussed this too in the previous video. Watch it. You can also use a round robin fashion. Round robin is like this. Round robin is like how they share food for us in our homes when we were younger. Some of you are probably not born, but they put the bowls there, then they scoop. Dining hall, they used to do that, right? Like it was dining hall. In year 1, year 2, year 3. Year 1, my time we were BVs. Year 2 were BUs. Year 3 were BTs, right? So they're pouring the milk, they'd be like, BV, 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 BU, BU. Then they go around again, right? Like they press, that's round robin. You serve this guy, you serve this guy, you serve this guy. Then when you get to the end, you come back, just a round robin fashion. You can modify round robin in different ways, but yeah. But the one we usually use is a consistent hashing for reasons, right? But there's so many algorithms you can use to distribute the load. So you can be like, I'm going to put a load balancer here that is going to distribute, our network requests using some algorithm. Let's say using consistent hashing. When you use consistent hashing, again, if you don't know, run away quickly. Then you move on. And then that's basically the load balancing aspect of it. What else is there to talk about? I've thought about a lot of things, but to be honest, I'm going to ask you to read the document, watch this video again if you have to, take a system. I can give you an example system. You can design, if you have an upcoming interview goal next week, design it if you want, send me the documents you created yourself. I like people to write it out sometimes, because as you write out, you think more. These things, it's been so long. That's why I mocked somebody on this system was like a year and a half ago. It was like a year ago, actually. So yeah, if you want to mock, definitely ping me. We'll have a mock interview. I can bring a system you already know or another system, but they basically follow the same framework. Trust me, if you do this, when I did my first system design interview with Netflix, I hadn't done system design specifically. I have built web applications and stuff like that. Actually, I got a very popular question though. It's also I've shared some design book with you before. So this is what I'll do if I have an upcoming system design interview. Number one, watch our system design recordings. I know some of you have already watched it. Go through this today's session. When you're done, go online, look for system design mock interviews. There's one I had. I think I saved. I'll send the link again. Watch them do the system design interview. The one you watch will probably be some guy who's a senior engineer. It's fine. Watch it. Some things you mentioned, you don't need it. Like you focus on the bandwidth, the specific things it's not expected required for you. But still watch it to see how he does it, right? How he does the high level design, how he goes deeper into it and everything. When you're done, I sent you people a book, a system design book. Take that book if you can. Just choose one system, and just read the solution. Let me just show you right now. Just read that. If you have time, just read the solution to that. It could be a tiny URL system. I got a type ahead system when I got into Netflix like 2 years ago. A type ahead system. I had never done this. I have never done it. It just, thank God, I needed a personal algorithm. So I'm like, I'm going to use a try. Those of you remember the try. It's really good for storing data. Type ahead is like, as you are watching a movie. Last week I looked up Chewa on YouTube. YouTube actually has Chewa, part 1 to part 12. I looked up Chewa. So you see, in Netflix, if you're typing Chewa, you type K-Y-E, it will suggest like Chewa, Chinchinga, Kalawili, and so on. Actually, don't do Kalawili. But, just suggest this. That's the type ahead system, right? It suggests things for you and just kind of tries to auto-complete it for you. And I'm like, oh, the try is a good data structure. And I just apply that. I'm like, it loads the data, source in the memory, and so on and so forth. But goodness, I got in. That's why I'm like, if you get Netflix around, you don't get the offer. You and I, we have an issue. But yeah, so that's what I'm going to do. Number one, watch our previous video. Number two, watch this video again. Number three, watch a mock interview. Watch 2 or 3 if you need on YouTube, and go through one other system from the book we shared. It's good. Just read one system also if you want. And if you want a mock interview, just ping me. Let's have a mock interview. Let me mock maybe 2 of you together. We just do one person and the next person. Do we have questions? Oh, there's more to the non-functional though. You see it if you go through the thing I said. Yeah. Any questions? We are over 1 hour. Any questions? Blay has a question. Samir has a question. Yeah, Blay first.
Yeah. Can you go back to the page with the load balancer?
Yeah. There's actually a bit more to that, but yeah, ask your question. Maybe don't make a sense more on it.
Like, does the response go straight to the client or go back to the load balancer?
Exactly. See, that's a good question. Now, I said these things are called proxies, right? We put them in the middle of the system. At a time where you are focusing on these additional additives, you don't need to be like the client sends the load balancer sends to the server, then the server brings it. No, just tell us what the load balancer is doing. Don't bother yourself with the flow again, right? We've already told us the flow, right? You've shown us just this how the flow works. Does that make sense? So if you're not really sure how these extra things change, see, I introduced a cache and everything, but when I got to the network place, found out it's going to be an HTTP request, and it's going to be, let's say, encrypted using HTTPS and so forth. See, I didn't even mention cache again. I didn't mention my CDNs again. Oh, by the way, if the data that is being brought from the server to the client, if it's, let's say, media, like pictures or videos, the type of cache we use is called a CDN. I taught it weeks ago, a content delivery network, right? Like Cloudinary, Cloudflare, this one beginning to see. But yeah, basically, it doesn't need to come back to the load balancer, right? But depends on the design of the system. Now, I mentioned something called the gateway. Now, the gateway is also less another computer, right? Here, the gateway can contain the load balancer here, as I said. And it also it has the load balancer. It also performs other functionalities, right? Sometimes you make the request to the gateway will redirect it to a server, a worker node here. The response comes back to the gateway. Because maybe this is what happens. Look, maybe this is what happens. This guy sends the data in the form of, let's say, some bytes, right? Sends it in some let's say bytes array or some binary formats, right? Let's say BSON, binary JSON, BSON. What is it? Let's say this guy makes a request using, let's say, JSON, makes a request in the form of a JSON. The JSON comes here. Then here it sends in the form of a BSON here, or maybe JSON. Maybe let's say it also sends back here JSON. But this guy returns a BSON to the gateway. Now, the BSON cannot probably be processed by your client. So if it sends the BSON is just binary JSON in binary format. Your client cannot process the BSON, but it will bring it to the gateway. And then the gateway has the mechanism, has the code to convert your BSON to a JSON, right? So it all depends on the design of the system, right? See, that's software engineering. You know, I read a post on Reddit last week, and somebody was like, computer science is not a creative field. I'm like, bro, you just know HTML and CSS, saying it's not creative. It's so creative. Like, by God's grace, I work on a databases team and we build things like this, right? And that's also one reason I know some of these things, because of the project I work on. I'm here at Microsoft, and very cool stuff. And people are so smart, right? They design amazing systems, like beautiful systems. And then the gateways, like our gateway is written in C#. So like it's a database. So let's somebody makes a request. Let's say select. So basically the users, so we take a MongoDB query, a Mongo query from the user, and then but then our database is actually a Postgres database. See the cool thing. So they make the Mongo query. So Mongo will be like db.collection.find, right? Find all the data in this database or in this collection. But it comes to the gateway, it's written in C#. Then the C# will rewrite it. As I told you, I said that database is in Postgres, right? So it will rewrite this Mongo thing, this Mongo query into our custom Postgres. So it should be like select document from our API our database is called HelioDB. So we call it Helio API. It's been open source soon. When it gets open source, I'll share the link with you before. .helioapi.collection.this. Then to come here. This is our server. We'll do all the magic we do here in a PG Mongo engine, and then we source in the Postgres database, and to return the request in some format. This format can be BSON or something. Then the gateway would then, MongoDB expects the data in the form of a JSON, right? Then this guy will reprocess the gateway, reprocess it in the form of JSON and to bring it back to you, right? So it's like the design is so beautiful. It's so amazing, right? And it's complicated. That is why I'm like, when I'm talking about these additives and these extra parts, you don't need to focus so much on the flow. Be like, so now I'm talking about scalability. If we have, let's say, a lot of users, a lot of clients that are interacting with our service, what we can do is that we can put a load balancer between our clients and between our app servers. And this load balancer would just distribute the load from the clients to the different servers using an algorithm such as consistent hashing. I'm done. I just move on. I'm not going to be like, send to the load balancer, send it to this, bring it back to this, bring it back to that. You don't need that, right? And you just move on. Does that make sense?
Yeah.
Please, the others, does that make sense to you?
Yeah.
Okay. API, API gateway. So I thought about the API gateway. So an API gateway can redirect requests. It can have a load balancer in it. Can do a lot of cool stuff, actually. What else? Oh yeah, going to Netflix. Going to Netflix like, what was it, 2 years ago? Yeah, but I chose Microsoft over them. Any other thing? It was an amazing team, actually. It was such an amazing. I think my manager, he's so smart. He was so excited to have me in every team. And it was Christmas time, right? He's got Itai. He's an amazing. I connected with him on LinkedIn. My interview was also for Adam Jordans. Nice guy. He looked me up on LinkedIn. We connected everything. Man probably thought I was coming. He's like, okay, so I'll see you. He's Jewish, so he was going to Israel for the Christmas break. So man thought he has his intern, so he's going to. He's an amazing guy, but I had chosen to go to Microsoft. I don't regret. I don't know. It was an amazing, but we were both amazing. And I like the project I also working at Microsoft. I'm on a database team, systems, it's very cool stuff. That's why I also decided to return here full time, even I could have gone to somewhere else. But I don't regret, honestly. They're both amazing teams. I think it's good if you get into it. I know some of you are getting multiple offers and stuff like that. I'll say prioritize your learning. If you're international, definitely your security matters. But by God's grace, the things you can control, you leave them. But if you get comparable offers, care about your team, the things you get to work on. You get to learn these things, right? I really like what I'm doing and what I'm learning, and it's been so long I learned these things again from Boost Anything. But the project I work on also teach me a couple of things. So yeah, prioritize what you learn at the start of the experience, not just company names or stuff like that, or not even just compensation, to be honest. Prioritize your learning if you get the chance. Yeah. Anything else? Yeah, Sammy, what was the question?
Okay, Sammy, after you.
Cornelius, I was kind of curious. So the load balancer is the one sharing like the request, right?
Yeah, it distributes the request, right? So it's like, so let's say, imagine this, right? Let's say it does more than just distribute the request. Sometimes, so imagine this, right? That let's take some websites. If you take the US, right? If you take what website do students use? Let's say Canvas, right? Canvas is mainly accessed on campus. Let's say Instagram, right? Instagram almost likely be accessed by people in some a population where they are more youthful, right? So so there are all the requests are coming. It's a lot of requests coming in, right? So you can have this server here having, let's say, a large CPU. CPU simply means processing units. Like you can have it as energy, right? Yeah, let's say 30 CPU, right? It has power 30, it has power 10, right? There's so many requests coming in. Ideally, you want to put most of the load on this guy, right? And put as little as you can on this guy, right? Let's say 20. You want to like balance the load on them, right? But balancing the load is also not that easy. It needs an algorithm, right? Because if you don't take care, in an attempt to balance, you may end up putting more on one and putting less on the other, right? There's also much with imagine that you're balancing the load. Now, servers can crash, computers can fail. What if this guy dies? The load balancer may not know to still try to put everything on this guy, right? And then the guys who are trying to access Instagram, whose requests are being sent to this guy, will never get a response, and they'll be like, Instagram is down, right? So there's more to the system. You know what we do? That we do something called health probing. Health probe. So that is, let's say it'd be like after every 15 seconds, hey, every server should let me know if they are still alive, right? So usually it's like this. How to get to it? Diagram somewhere here. It's like, so here it'd be like, hey, every load balancer is also like a computer, right? In some systems, they can make it the worker node or the coordinator. They just call it a coordinator, which has that logic inside it, right? It's just like code, like just software. So like every 30 seconds, all the servers I speak with, everybody, let me know if you are still awake, right? You can also let me know if you're awake and how much you're working on, right? But it's like the 30 guy can be like, hey, I know, but I have just one of my energy remaining, right? So can you just not bring me more requests, right? So they always give health status, right? So that the load balancer can then shift it to the other ones, right? Also, you can die when it dies. When it dies, let's say in a data center, I told you these are servers, right? In the data center, like a rack like this, I said the servers are also like usually in a racks. There's a system called an orchestrator. The orchestrator can replace a server. So if this guy dies, there could be a free server somewhere, right? Usually this is how the cloud works. There's a lot of servers, right? There's a lot of servers, right? Some of them are being used, some of them are not being used. Some of them fail, then we can take those that are not being used to come and replace. Some of my professors work on this startup called Exotanium. Usually what they do is this. They come to, let's say, Azure or Google Cloud and be like, hey, those servers that are not being used, give them to us. We want to provide services to other companies, other startups, when those servers are not being used, using your service. So basically, they'll go sign a contract with these companies. The companies give them access to their backup servers, and then they use those backup servers to serve other companies at a cheaper price, right? Because these servers are not being used in companies. Lots of servers that are not being used, honestly. And it's a very good business idea, right? And they're very good. They're very smart people. Two of my professors, at least, one I came to Ghana with RVR, and the other is also came with us. This came to Ghana like 3 years ago. And orchestrator is just like some watchman guy, be like, hey, server, you are broken. Put the next one in. Just be like, oh, yeah, it's called an orchestrator.
Cornelius, I didn't finish my question.
Oh, so yeah, so the load balancer just routes the request right to them. You say you didn't finish, go on.
Yeah, I'm saying that so the load balancer takes like every request and distributes it, right? So doing like so much work, can you have like multiple load balancers?
Yeah, that's the thing. It also gets duplicated. Like almost everything is replicated. That's the thing. We have something called a single point of failure. In a distributed system or in a cloud setting, you almost always never want to have one thing. We never do that because computers can crash. Everything can crash. That's the thing. anything can crash anywhere. So we replicate everything. So it's actually a problem so systems have problems, right? See, when people are doing research, like distributed systems it's a complicated field. There's no 100% guarantee on anything. Everything can crash. So you know what some people do, what some designs people have. So you'd be like, okay, look at the thing that will happen. You'd be like, okay, we have this, right? Look at the system distributed systems. Look at this. You have these servers, right? Let's call them server B. These are the vector servers, right? They're like, okay, I'm going to have a load balancer that is going to speak with them. Look at this funny thing. We're like, my load server 2 can crash. That means I need to replicate that too, right? But then wait, something might also redirect the request to these guys. Do you see how the thing is? Let's say put that thing here. But that thing too is 1 now. You're like, oh, that thing too can crash. Then let's replicate that too. Feel like that at some point you're going to need one thing. You're going to need like one guy. Can you see it? We're going to need one guy here who will be like the main entry point to these other things. Can you all see the picture I'm trying to draw here?
Yeah.
Wait, can everybody see this picture? That's the replication. This duplication we're doing here kind of like gets propagated, but you're still going to need some one point where everything is going to emerge from. Can we all see that?
Yeah.
Wait, others, do you all see the picture?
Yeah.
But then that also brings that thing. We still don't want to have single point of failure. So then what do some engineers do? Cool people, smart people came up with this thing. If this guy crashes, this is what we're going to do. We're going to make you think the client has crashed. So you make a request sometimes in your browser. This guy has crashed, response has not come. It makes it look as if it is your computer that has crashed. They have protocols for achieving that. See, engineers are so smart that they be like, you're using your phone and the server thing has crashed, right? But then make it feel as if it is your browser that has crashed or anything like that. Yeah, that's something they do. Because if they don't do that, they don't look as if everything has to be replicated. It becomes a recursive thing. Like it never gets fixed. So that's one thing. Make it seem as if the client has crashed. There's actually some guy who proposed that. I've forgotten the name. It's called so I've forgotten the name. I think I learned my distributed systems. So this at Cornell, definitely try to take CS5440 with my favorite professor, Lorenzo Alvisi, smart guy. He does me distributed systems. The readings are online too if you want to do the research paper readings. But yeah, that's what some people do. But yeah, they can all crash, single point of failure. Okay, that's it for today. Please go by this if you have to. Go by the
Some people
I have,
Oh, hands are up. Oh, let's take those questions finally. Okay, Simon had their hand up first. Simon, then after that, Elikem.
Yeah, so I had the same question last year when I was interviewing, and one thing they asked me, I know you mentioned it already about the authentication and all that, but they asked to also show how when the user goes onto the app or the web page, how does the user get access to the movie? So kind of designing how the user is gonna log in and access, So I had to design that as a site also.
Yeah. Exactly. So what you mentioned. So he got this question, right? So I'm like, we mentioned all these different parts, right? Like you said, without the authentication statement, please note them. Like it's not really different, right? Like it's the same structure that we talk about. One computer here, some database here. How do you log in? And see, make it real world, right? When you're logging in, so you log into accounts. What do you submit? You submit this and this. Like, so on our login web page, on our login front end, we have a username and a password. We submit it in the form of a form. The form contains this and that. When it gets here, the password is then the user is then authenticated. We fetch the email, these account, we compare. You are there. If we get authenticated, the token gets sent here. Wait, let me see if I have a document. I probably may have a document. Do I have a login? But I probably don't. Should we create more? I like to type them out so that people can read it at their own. I don't. Wait, let me check my thing. I have actually, wait. I think I created one for a type ahead too. I used to create some of these documents last year for. I will check and see. But yeah, please be very open-minded. These few things we have gone over, you can definitely extend them, right? And as you do it, like just be open-minded, right? Some of these things, I'll say go over a dynamic recommendation system, go over a authentication system, go over an online multiplayer game. The game system is not scary. Literally the same thing here. The game thing is just get put into servers, a web server, an app server. The games are graphics. That means you're going to use a CDN here. Just put in a CDN here. I said CDN if the server is bringing graphics or anything or music or any of those things. CDN is good for those static files, right? just for them here, cache it in the form of a C, and that is your cache. That's the same cache you put here. So this cache guy is storing movies data and stuff, but this guy can store pictures and that. And also consider the game logic. Consider the thing that are going to show on the game thing. There's also more, actually, there's a bit more to the game one though, like the interactivity and everything. Should I write a document on game and then share that too? I will try and do that. But see, you go about these things. Another measures I've mentioned. Request a mock interview. I can probably use one of the mock interviews to do that. If I have an upcoming interview, maybe call next week or next 2 weeks. Let's do that. And yeah, pretty much. And please, you'll be fine. Don't just be open-minded. If you don't know something, you're not sure about something, ask. Again, you are a college student. Nobody's going to. It will be that easy. They wouldn't have tens and hundreds of people designing and building these systems. Watch some quick YouTube videos if you want to, but still go over our materials. Watch a mock interview online. Yeah, and yeah, just read one title. Let me show you the book before we go. Okay, I'll ask you a question. Ask a question.
Well, I'm just going to ask about the book.
Oh, the book. Okay, yeah, let me show you that. I think I still have it. My back is hurting. It's called Old Age. I know I shared the book before, but let's find it again. We are here for that. Screen 1. Okay, I usually call my books. I probably call it somewhere. I had a personal copy of it, which I had markings in it. But let me give you this. I think I'm sharing it in the. So go to this book, right? And if you go to this book, this is what you can do. But please watch our recordings first. Then you can come to this book. Then you can watch the mock interview. You can do it in that way. So what you can do is you can come down here. I think down here they have general concepts. The book is very easy to read. Those who don't like reading, I beg. This book is very easy to read. See, you can literally sit down tonight and finish this part I'm coming to show you. This part is the system design basics. It talks about key characters of distributed systems. Sorry. Scroll. How did I get here? Oh, I clicked it. They are linked, so don't click. Okay. The key characteristics, it'll walk you through like, so it will teach you like things like load balancing, benefits of load balancing, caching, CCDN, caching validation. You don't need to know them in detail, but you can just read through this. It's just very few pages. It's from page 169 to like 189. You don't need to know Ajax polling, HTTP WebSockets. If you're designing, let's say a text app, like it's a chat feature, definitely needs sockets. Server sent events to Simon, you're the one I worked through with, right? Server sent events in Ajax poll. Constant hashing, we mentioned that you can just skip through these fundamentals, honestly, if you can. Indexes, we talked about indexes 2 weeks ago, right? And so on. Then you come here, just pick one question here. So see, if I had gone through this thing, so this is the question I got. So you can, the type ahead system. See, they used the try to, they copied me. But you can just pick one of these systems, honestly. You can do the design YouTube on Netflix. You can pick this one if you have listening to the interview coming up. Let's pick one of these systems and just go through it, right? This is what I was talking about. Like, see, like if you pick this one, let's say design YouTube on Netflix, and then someone even had the interview like last week, they got design Netflix, right? If you have gone through this is a part I'm saying don't fixate on these math and those things. Like nobody's going to stress you on that. How the API, we talked about this API design, it's a GET request, it's a high level design, that we talk about that. Oh, they're even using a queue here, right? See, they have a user database, they have a storage for the video, that's what we call the movie DB. And see, they just have these things here, just put this in it. See, they also have a web server and an app server, right? The app server contains the logic, the web server is what you speak to, the client speaks to the web server. And for Netflix, there's some functionalities, upload, search, view. So just go through one of these things. Then so after you've done the high level, then we go into detailed components design, right? That's where we took it one after the other. We took like the database, went into it, how the processing is going to work. For the recommendation, we're like going to use a machine learning algorithm. I think I specified a bit more information on if you open the doc, where's the doc I showed you people? Yes, I think I talked a bit more about that. Yes, I talked about DB. Did I not? Thought I did. Or did I not? This is a recommender service. Did I not chill a bit? Go too lazy when I was typing? Yeah. So I'm like, yeah. collaborative filtering. You can talk a bit more about how that part is going to work. There's a book. Oh, sorry, I didn't open it. I just clicked through. But yeah, just go through one of these questions. But again, don't spend too much time on I know people fixate too much on the numbers, on those numbers. These ones, you don't need to. You're not doing some senior level or something. Yeah, and just video duplication, load balancing. See, they also use consistent hashing. It's actually kind of the most popular one. We discussed this last in a previous video. You can also read that section on it. Caching, we talked about caching. CDN, right? Like for instance, CDN is used for, we talked about that. Fault tolerance. That is, if one system breaks, how are you going to do that? How are you going to handle it? It helps you replicate, blah, blah, blah. So yeah, that's all we have for today. Anybody has any questions? Sorry, we've been 1 hour 30 minutes in. So what did you say?
Can you put the book in Tech Elevate?
Yes, it should be in, but let's just put it in there again. Why not? I'm sure it should be in. Let's see. Yeah, I put it in. Yeah, I even told someone to just refer it. Okay, that's fine. Let's find it. Let's look up all our files. I don't even, is there a way to even get all your files from Slack? Okay, I just upload it again. But I know I shared it. Look, just type book. We just type book. Actually, don't bring it to. Nah, see, I just resend it. Let me send it right now. Discussions. This one may have my highlights. Let me send the one without the highlights, or see, it doesn't matter. Okay, I'll send both. I think this one has the highlights, right? Yeah, I read this like when I was in second or third year. Okay, this wasn't even this one. The one I had has probably more highlights. Okay, this one, yeah. You can, if you see guys late, just read the highlights I've made. Like go to the base. The base part is down. So scroll down, that's down, right? System design basics. And yeah, I read it like many years ago, like 2 years ago. So yeah, so can you just read this? Let me just target system design. Oh yeah, and let me show you the YouTube one. So what I said you can do. So if you go to YouTube, right? There's a guy I watch sometime. So you just go there like this. There's some guy. You just want to market. I don't need the base necessarily. I mean, if you have time, sure. But there's a certain guy. Let's see.
Can the person recording also upload this one and then the previous one to like a Google Drive instead of like
instead of YouTube?
Yeah, I don't know if he has access to the YouTube. That's why I'm proposing
that's so true. Okay, Sammy. Okay, so I'll give you the YouTube. Yeah, this guy. Yeah, this one. I think this guy is good. Yeah, if you guys look, so this one. Hello. Not go up this guy, but I think what system was this? WhatsApp or Telegram? You can look at the other. Okay, look, I watch this one as you can see. I watched part of
initially when the web.
Right, you can forget his numbers portion, honestly. Like, I think this guy's channel is that bad.
Not sharing your screen. No.
I'm not sharing my screen.
Yeah, you are the one doing.
I'm having the fun myself. Oh, sorry. I thought I was. Oh, sorry. Can you see my screen now?
Yeah.
Yeah, you can watch like a mock interview like with this guy, right? Like this here was designing Spotify. I think his isn't that bad. He talks about like he goes see high level. He puts a little bit in early, but don't do that at the first. DB he puts his database there. So yeah, so it sounds like the platform is just like this, right? Like you just put in there. But if you don't use this guy, so you see the schema for your database, you're going to saw their songs and like just watch a mock interview with some guy, it doesn't have to be this guy, but I think this guy isn't that bad. But yeah, so Sammy, I'll give you the thing so they can upload the video. Ping me, I'll send you the account details, and then you can do that. Okay, people. By the way, if you want to watch this, if she doesn't have if she doesn't have these traits, don't marry her. I don't know how they got recommended that, but I'm good on that front. Okay, I think we're good with that. Anybody has any questions? So just do these 3 things. If you want to mock, ping me. I'm trying to schedule mocks, but if you have mocks, just ping me on that, and then we shall see. Sounds good. Yeah, we've done like 1 hour 40 minutes today. Yeah, we good? Oh, is there anything in the chat I need to answer? Oh yeah, someone also recommended something. That's also good. Yeah, someone says Striver. Yeah, Kevin, you can send it to the Slack too, so people can easily see. Okay, thank you guys for coming. Yeah, God bless you all. See you when I see you. Simon, can stop recording.
Thank you.